Dear participants, let's wait for a couple of minutes to give everyone time to join. Morning to one and all. On behalf of St. Joseph's College of Engineering and Technology, Palai Autonomous, I extend a warm and cordial welcome to each one of you to the inaugural ceremony of the 5-day online faculty enablement program on natural language processing and explainable AI, faculty immersion in the era of large language models. This program is organized by Department of Artificial Intelligence and Data Science, SJCT Palai, in association with Corporate Relations, Training and Placement, SJCT, and conducted in collaboration with Tata Consultancy Services, Kochi. This FEP is a significant initiative to equip educators with future-ready skills focusing on natural language processing, explainable AI, large language models, and responsible AI, thereby bridging academia with industry advancements. With these words of introduction, let us now formally commence the inaugural session. Dr. V.P. Devasya, a respected principal, is a visionary academic leader who has always encouraged initiatives that bridge academia with industry. Now, I invite a respected principal to deliver the welcome address.
Hello, am I not audible?
Yes, sir.
A very good morning to one and all present. Respected Director, Reverend Professor Dr. James John Mangalatha, our distinguished guest Mr. Raju Srinivas, my dear colleagues and all the participants present here today. As we all know, technology is moving fast, and as educators, it is our job to stay ahead to groom the youngsters. Today, people are always talking about the transformative changes happening in the domain of artificial intelligence. Our country has taken this domain as a thrust area to focus the maximum so that we always stay ahead globally. This program is a unique chance for us to learn from the best at TCX and arm ourselves with the knowledge we need to guide our students. It's a collaborative journey, and I encourage everyone to make the maximum out of it. We at SJCET are always offering state-of-the-art programs in engineering. Being an autonomous institution, we now have the freedom to move forward at a faster pace. This faculty enablement program on natural language processing and explainable AI is organized by the Department of Artificial Intelligence and Data Science and the Training and Placement Division at SJCET with the active industry partnership of the technical giants of this country, the Tata Consultancy Services. Without taking much of your time, it's my pleasure to formally welcome all of you to this program, especially to this inaugural session. Firstly, a special welcome to our beloved director, Reverend Professor Dr. James John Mangalat. He has been an academician, researcher, and administrator over decades. After leaving an unmaskable footprint at the reputed institution, the St. Thomas College, Palay, as the principal, he has joined with us as the director. In addition, he is having the additional responsibility as the administrator at our sister institution, the St. Joseph's Institute of Hotel Management and Catering Technology. Dear Father, your involved leadership is truly bringing our institution to better heights. On behalf of all those who have joined here, I extend a warm welcome to you. Now, we are also incredibly grateful to our partners from Tata Consultancy Services. They have thought this fantastic or brought this fantastic initiative to us through the TCS outreach program with 100% resource support from their side. We thank them for empowering us with this opportunity. The keynote speaker, Mr. Raju Srinivas, Corporate Alliance Head at TCS, is a beacon of inspiration and a non-orator and a motivator. Your presence here today is a true testament to the value of this partnership, and we are all excited to learn from your expertise. On behalf of St. Joseph's College of Engineering and Technology and all those who are present here, sir, I extend a warm welcome to you. Dear participants, it's heartening to note that more than 100 faculty members have joined this program. But as of now, the attendance is a bit less. Hopefully, they will be joining soon. I know this is a very busy time for all the academicians from the institutions as the classes are in full swing. And the fresh students have already joined. In spite of that, you have set apart time to equip yourself to be better teachers and mentors. On behalf of the organizers at SJCET, I welcome all of you to this program. This is organized by the Department of Artificial Intelligence and Data Science under the headship of Dr. Ranjit Thomas, jointly with the Training and Placement Division led by the dedicated placement officer, Mr. Sachin Jose. While thanking them for their earnest efforts, let me welcome the whole team for organizing such a wonderful program in association with TCS. Also, there are a lot of colleagues joined in this program. The Vice Principal, Reverend Dr. Joseph Periyadathil, heads of various departments, other officials from Tata Consultancy Services, my colleagues at SJCET, and all. I welcome all of them to this function. So, once again, a very warm welcome to all of you. Let's get started. Thank you.
Thank you, sir, for your warm words of welcome and encouragement. I now invite our beloved director, Reverend Father James John Mangalata, a professor with 22 years of teaching experience and a constant source of guidance and inspiration for the SJCT community, to inaugurate the program and deliver the inaugural address. Sir, not audible. Father, it's not audible.
Hello. Disconnect. Hello, am I audible now?
Yes. Father, your mic is muted actually.
Is it okay?
Yeah.
Dr. V.P. Devasya, the principal of St. Joseph's College of Engineering.
Father, now it's actually not audible.
Mr. Rajiv Srinivas, Head Kerala Region Academic Alliance Group, TCS Kochi. Dr. Joseph Pureyadathil, the Vice Principal. Dr. Denjit Thomas, HOD. Mr. Sachin Jose, the Coordinator. Distinguished guests from TCS, officials from SJCT Pale, and dear participants from across India. It is my honor and privilege to be part of this faculty enablement program on natural language processing and explainable AI, organized by SJCT Pale in partnership with Tata Consultancy Services, a global leader in technology and innovation. Today, we gather not just as teachers, but as learners and leaders shaping the future of education. AI, especially tools like ChatGPT and large language models, is changing the way how we teach, learn, and solve problems. In the ever evolving landscape of artificial intelligence, two areas have emerged as both critical and transformative: natural language processing and explainable AI. Together, they are reshaping how we build intelligent systems and how we as human beings can understand, trust, and interact with them. Natural language processing, once a dream of science fiction, is now the backbone of modern communication between humans and machines. From chatbots that assist customers to voice assistants that make our lives easier to advanced translation systems that break language barriers, NLP has touched nearly every dimension of our personal and professional worlds. For educators and researchers, the power of NLP lies not only in application, but also in the ability to inspire innovation
Getting
among
this noise from
students who
here
will
also.
carry
I was just wondering, where is this noise coming?
in application, but also the ability to inspire innovation among students who will carry this revolution forward. But with greater power comes an equally great responsibility. As AI systems become more complex, the question of trust becomes paramount. This is where explainable AI takes center stage. A model that delivers high accuracy is valuable, but a model that can explain why and how it arrived at its decision is priceless, especially in domains like healthcare, finance, law, and governance, where accountability and transparency are non-negotiable. Explainable AI bridges the gap between machine intelligence and human trust, ensuring that technology remains not only powerful but also ethical. Here is what I believe. The future of education is not about replacing teachers with AI, but about teachers who can guide AI. Just as a lighthouse directs ships, our faculty must illuminate the path for our students to use AI wisely, ethically, and creatively. This program with the TCS expertise will help you master these tools so you can return to your classrooms, whether in Kerala, Karnataka, Punjab, or Assam, or Tamil Nadu, and inspire the next generation. The very term faculty enablement instead of development refers to skill acquisition. To all the faculty here, I understand that there are over 150 registered participants. Let us take this opportunity to learn, share, and grow together. Best teachers never stop being students. We are happy to collaborate with the TCS with these types of activities because I personally believe that Tata is the best organization in India that functions with a firm ethics and social commitment. The other day, I had a personal interaction with Mr. Rajiv Srinivas, and I myself confirmed the above statement. I thank him personally for his association with St. Joseph's. I congratulate the organizers, especially Dr. Ranjit Thomas, the head of the Department of Artificial Intelligence and Data Science, and also Mr. Sachin Jose for their leading role in conducting this kind of a program here. And I also thank the Data Consultancy Service for this academic partnership and wish everyone a rewarding experience. Let us get enabled. With these words, I declare this national level faculty enablement program on natural language processing and explainable AI inaugurated. Thank you very much.
Thank you, Father, for your inspiring inaugural message. It's now my pleasure to invite our keynote speaker, Mr. Rajiv Srinivas, head of the Kerala region, Academic Alliances Group, TCS Kochi, an eminent leader who has been instrumental in building strong academia industry collaborations across the state to deliver the keynote address.
Thank you so much, Nina ma'am. Good morning, one and all. I am a bit skeptical now after Professor Dr. James John's speech. What can I else add on to it? That is the way he always addressed the stage. And thank you so much, I would say, from the bottom of my heart, for this wonderful opportunity to collaborate with esteemed organization like St. Joseph's, which is really evident from the participant counts here. We are nearly hitting the century, 99 people already in the online crowd here, which truly showcases that we are all here to learn and further enhance ourselves. This faculty enablement program, excellence program, or development program, whichever way we call it, I believe will be true testimony, which is the need of the hour, especially now, where we are more investing into the AI technologies. And I truly believe all the experts from our TCS who readily accepted the invite of, yes, we are ready to take it up. So special thanks to all those members who stood forward and took the initiative to come forward. And of course, I can't thank enough for all the professors of the AI department and our PO Sachin sir to make this going on. And I would always see that I have personally met him sir and all who had been already a pioneer leader who are visioning more than enough to see like what else we can add on. It's not about making safe with what we have. It's always curious to add on what we can. So I'm really glad that we are stepping forward with the visionary initiatives that we have. And special thanks to Principal Devasya sir and all who had been spearheading this initiatives. I have met these people who were a great personalities among themselves who had the vision to bring forward. So I wish all the very best in the coming days, and I'm sure we'll be having a wonderful session. Looking forward for the honest feedback and looking forward to more colorful days. Thank you so much for this time. Back to you, Neil.
Thank you, sir, for your keynote address and for setting the right tone for this program. As a token of our gratitude, we now present a virtual memento to you, sir. We request you to kindly accept this gesture of appreciation from the entire SGCT community. To conclude the inaugural session, I invite Mr. Sachin Jose, co-coordinator of this program, to deliver the word of thanks.
Good morning, ladies and gentlemen. It's my privilege and honor to deliver the vote of thanks on this significant occasion, the inaugural ceremony of the FDP on NL processing and explainable AI. On behalf of the organizing committee, I extend my heartfelt gratitude to our esteemed director, Reverend Dr. James John Mangalatha, whose visionary and effective leadership and constant encouragement makes initiatives like this possible. Sir, your continued support for academic enrichment and faculty development truly sets the pitch for innovation on our campus. Thank you for gracing this event with your presence and insights. Thank you, sir. A special word of thanks to our respected principal, Dr. V.P. Devasya, for being the driving force behind academic excellence in our institution. Your commitment to continuous learning and faculty empowerment is deeply appreciated. Not to mention the Vice Principal, Reverend Dr. Joseph Puredathil, the young and the refreshing face of the executive. Thank you, sirs. May I thank Mr. Rajiv Srinivas, the young and energetic leader of TCS and coordinator, whose exemplary professional life is a beacon for us and the generations to come. Thank you, sir. I also extend my sincere thanks to the head of the departments, the deans, and the other men of significance. Your cooperation and encouragement have played a crucial role in bringing together faculty members across disciplines to engage in this transformative learning journey. To our invited speakers, participants, thank you for your enthusiasm and willingness to immerse yourselves in the cutting-edge domains of NLP, explainable AI, and LLMs. Your participation will undoubtedly make this program a platform for collaborative learning and growth. Finally, I express gratitude to all the organizing team members who have worked diligently behind the scenes to make this event a success. Let us carry forward the spirit of this FDP to explore, to learn, and to adapt in this era where technology and teaching are becoming more closely intertwined than ever before. Thank you all once again, and I wish the program great success ahead.
Thank you, sir, for expressing our collective gratitude so gracefully. With this, we conclude the inaugural ceremony of the 5-day online FEP on natural language processing and explainable AI. Before we begin today's technical session, let me briefly share a few guidelines. The FEP comprises 5 sessions scheduled from 10 a.m. to 12 p.m. on all program days. A minimum of 80% attendance is required in order to earn the certificate. The first technical session will now be led by Ms. Rahila T., machine learning engineer at TCS Kochi, who specializes in the natural language processing and AI solutions. She will be speaking on foundations of NLP. We warmly welcome you, ma'am, and invite you to begin the session.
Thank you. Thank you for your kind introduction. Let me share my screen. Before I begin, please confirm whether my slides are visible and my audio is clear.
It's visible and clear, ma'am.
Okay. So, good morning, everyone. Welcome to our first session of the series, Foundations of NLP. So, through this session, we will explore the foundations of NLP and understand how NLP is, we use the NLP in our real world, and how computer and machines can understand and work with human language. So let's start our session with the quotes from Alan Turing, who is considered as the father of modern computer science. Instead of teaching people how to talk to machines, NLP teaches machines how to understand people. So that is NLP, which stands for Natural Language Processing. It is an area of artificial intelligence that focuses on teaching computers how to understand and use human language. In other words, NLP helps computers read, write, listen, and even talk like people do. So that NLP is very important because it acts as a bridge between how humans communicate and how computers process information. Without NLP, computers could only respond to very simple commands like typing in numbers or clicking buttons like that. But with NLP, computers can understand questions, find information, and even have conversations with us. Now, you might wonder where we are using this NLP in our everyday life. For example, when you ask Siri or Alexa a question, NLP is working behind the scenes to understand what you said and give you a helpful answer. And another one is when you use Google Translate to change a sentence from one language to another. Again, NLP is what makes that possible. If you are typing email, it automatically sorts out spam messages in our email. That's again NLP. When you're searching something in Google or Bing, NLP helps the computer understand your question and find the best results. So NLP is not just one thing. It is a combination of ideas from computer science, artificial intelligence, machine learning, and linguistics. You may wonder where it will be a combination of this computer science AI. Here, computer science gives the tools to write programs and build systems, where AI, that is artificial intelligence, helps computers learn and make decisions. Coming to machine learning, it is a way for computers to learn from data and improve over time. Linguistics is the study of language, which helps us understand how words and sentences work. All these ideas come together in NLP to create systems that can analyze text and speech, understand what people mean, and even generate responses that make sense. This is why NLP is so powerful and why it is used in so many different applications today. This is the very beginning of the session to understand what is the NLP. Now, let's look at some real-world examples of NLP in action. NLP is used in many technologies that we use every day without even realizing it. Just like chatbots and virtual assistants like Siri, Alexa, and Google Assistants. These are some of the most common examples. These systems can understand spoken or typed questions and provide answers. They can do things like, excuse me. They can do things like set reminders, control smart home devices, answer general knowledge questions, like that. All of this is possible because of NLP, which helps the computer to understand what you are saying and give response that makes sense. Then coming to customer service, companies use NLP powered chatbots to talk to customers on their websites and apps. These chatbots can answer questions, help with the order, and give information quickly without the need of a human. So using this NLP possibility, they make customer support faster and available in a 24/7 basis. And another example is machine translation tools like Google Translate and Microsoft Translator. They use NLP to translate text or speech from one language to another. This helps people communicate across language barriers, even they are traveling, working, or just trying to understand something in other language. NLP is what allows the computer to analyze the structure and meaning of sentence and generate accurate translations. And next example is email filters. They use NLP to detect and block spam emails, keeping your inbox clean and safe every time. They can also categorize emails as important or not. And even they can suggest a replace based on the content of the message. Next one is search engines like Google and Bing. They are working heavily on NLP. When you type a question or a keyword into the search engine, NLP helps the computer to understand what you are looking for and find the most relevant result. NLP is used to analyze your query, interpret your intent, and then it is matching it to the best web page or image or other content. That is what is happening behind the search engines. Then coming to text summarization, this is another useful application of NLP. Document summarization tools, they use NLP to condense long articles or documents into shorter summaries. This helps people quickly get the main points without having to read the entire text. This is especially useful for busy professionals, researchers, and anyone who needs to process a lot of information quickly. They can use these text summarization tools. Then sentiment analysis. It is used by businesses to monitor product reviews, social media, and other online content. NLP helps determine if the text is a positive, negative, or neutral type. This allows companies to understand how customers feel about their products or feel about their services and then give response accordingly. Then coming to the next example, text extraction. Information extraction tools use NLP to pull out names, dates, locations, and other key facts from documents. This is useful in things like resume parsing and data scraping. It helps to automate data entry, build knowledge bases, and something like analyzing large amount of text quickly and accurately. For that, this text extraction is used. Then speech recognition systems, they also use NLP to convert spoken words into written text. This is used in voice to text tools and transcription apps. Here, NLP helps the computer to interpret different accents, speech styles, and background noise then making speech recognition more accurately and reliably. This is what happening in the speech recognition. Then coming to grammar checkers like Grammarly and Microsoft Word spell check, they use NLP to find and correct grammar, spelling, and even style mistakes. They help people write more better by suggesting improvements and explaining why certain changes are needed, so that we can use those changes to make our writing more better. Then predictive text. Predictive text features on smartphones like writing tools like Google Smart Compose. They use NLP to suggest the next word or phrase as you type. This makes typing more faster and easier, especially on mobile devices. On when you are in a hurry, uh, you can get a suggestions like when you are starting the typing. All of these examples shows how NLP is used in real world applications. NLP makes it possible for computers to understand, analyze, and generate human languages, which is why it is such an important and exciting field. Now, let's check at the history of NLP, how it has changed over time. NLP started with a simple rule-based system, then moved to statistical methods, and now uses advanced neural networks and transformers. Each step has brought in new capabilities and made NLP systems more powerful and useful. When looking to the history in detail, we can say traditional NLP began with rule-based methods. In the early days, people wrote rules for computers to follow, telling them how to parse sentences and understand grammar. For example, they might write a rule that says, if you see this word, it is a noun. This was the rule-based system. These systems were limited because they could only follow the rules they were given, and they struggled with ambiguity or new types of sentences. Later, researchers started using statistical methods. Instead of writing rules by hand, they let computers learn patterns from large data sets. For example, a computer might learn that certain words or they come together, or that certain patterns are common in questions. This made NLP systems more flexible and able to handle a wide range of language. After these statistical methods, classical machine learning came in picture. That is SVM and CRF. SVM stands for support vector machines, and CRF is conditional random fields. They are special algorithms that were used for classification and sequence labeling. SVM helps sort things into groups, like deciding if an email is spam or not. And CRF helps label things in order, like identifying names or dates in a sentence. That was doing by CRF. Both of these methods improved the accuracy and usefulness of NLP systems. Then modern NLP. Modern NLP is something advanced one. From 2010s onwards, deep learning started, where RNN, that is recurrent neural networks, and LSTM, long short-term memory. They are types of neural networks that can remember context over time. This means they can understand longer sentences and stories, so that making them much better at tasks like translation and text generation. So transformers are new type of models that can process entire sentences at once rather than word by word. They use a mechanism called attention to focus on the most important words in a sentence. This makes them faster and more accurate, and they can handle much longer and more complex text. That was the time of transformers. And then come BERT. BERT is bidirectional encoder representations from transformers. It is a powerful model that understands context from both directions. This means it can look at the words before and after a given word to understand its meaning. BERT is used in search engines, chatbots, and many other NLP applications. Then coming to LLM, that is large language models like GPT-4, ChatGPT. They are the most advanced NLP models today. They are trained on massive amount of text, and they can generate human-like responses, also answer questions, and even write code or stories for us. These models are very flexible and can be used for a wide range of tasks. So from this graph, we can understand how NLP has changed over time. It has moved from simple rule-based systems to very powerful data-driven models. It has become much more flexible and adaptable, able to handle new types of language and tasks. It has also moved from using small data sets to training on massive amount of text, which has greatly improved in its accuracy and our usefulness. So first thing is rule-based NLP methods. As we said, it is the system that use handcrafted rules to understand language. Experts in linguistics and computer science write rules that tells the computer how to parse the sentence, identify part of speech, and extract meaning like that. For example, a rule might say, if you see this word, this is a verb. Or if the sentence has this structure, it is a question. Like that, everything we have to write. Example of rule-based NLP include early chatbots like Eliza. Eliza was a simple program that could simulate conversation by following scripted rules. It was not very smart, but it showed that computers could interact with people using language. Then another example is grammar checkers. They use rules to check for grammar, spelling, and punctuation mistakes. For example, a rule might say, if the subject is singular, the verb must be singular too. Like that, there we use rules to check the grammar or spelling. Then information extraction tool. They use rules to pull out names, dates, and other facts from documents. Like a rule might say, if you see a word that starts with a capital letter and is followed by a last name, then it is a person's name. Like that, we create the rule to pull out the name. That was the information extraction system. Now, let's check how do rule-based systems work. They follow the rules that have been written for them. When they see a sentence, they try to match it to the rule and decide what to do. This can work well for simple or predictable language, but it was not very flexible. And this is the main limitation of the rule-based systems too. They struggle with ambiguity, new types of sentences, or language that does not follow the rules. They also require a lot manual effort to create and maintain these rules. Like if the language changes or a new domain is introduced, these rules have to be updated by hand. So this was the limitation of the rule-based system. Even though it has this type of limitations, rule-based NLP was an important foundation for early NLP systems. It showed that computers could process language and interact with people. Today, rule-based methods are still used in some domains where the rules are clear and very well defined, such as certain types of grammar checking or like some information extraction. In such cases, we are still using rule-based methods. Now, moving to the second thing, that is statistical method. These are systems that use math and data to find patterns in language. Instead of following handcrafted rules, they learn from large data sets. This makes them more flexible and more able to handle a wide range of language. Example of statistical NLP include language models, text classification, and machine translation. Language model, in the sense, they predict the next word in a sentence. You might have seen this feature like when your phone suggests the next word as you type. That is the language model example in statistical NLP. This model uses probabilities to guess what word is most likely to come next based on the words that came before. Then text classification. It is used to sort text into groups. For example, an email filter, which use statistical method to decide if an email is spam or not. So this system look at the words and patterns in the email and make a prediction based on what it has learned from previous examples, whether this email will be a spam or not. Now coming to machine translation, it uses statistical methods to translate text from one language to another. It learns from large collection of text in both languages, and then it finds patterns that help it to generate accurate translations. Statistical methods works like they analyze things like word frequencies, n-grams. N-grams means groups of words, and co-occurrence, which means which words appear together. Like they analyze these things, and also they use probabilities to make predictions. For example, a language model might predict that cat is more likely to follow than banana. And it has some advantages like statistical methods are more flexible than rule-based systems. And they can handle new and unexpected language as long as they have seen similar examples in their training data. They can also learn from data and improve over time, especially as more data becomes available. Not only advantages, it has some limitations too. The main limitation is that they require large amount of labeled data to train. If the data is not good or not enough, the system will not perform well. They also cannot always handle complex language, especially if it is very different from what they have seen before, they can't handle. That is one limitation. Now, SVM and CRF. They are more very important tools used in NLP to help computers understand and organize text. SVM or support vector machine that helps computers to decide which group something belongs to. For example, it can look at an email and decide if it is a spam or not. It does this by learning from many examples of spam and not spam emails. And CRF or conditional random field is used when we want to label part of sequence. For example, in a sentence, it can label which words are names of people or places or dates, like that. It looks at the whole sentence and decides the best label for each word. Both these SVM and CRF learn by looking at examples that have already been labeled by human. This is called supervised learning. They use a map to find the patterns in the data and then apply those patterns to new text. These tools are very useful because they help computers to organize and understand the text better. They are widely used in many NLP tasks like spam detection, named entity recognition, or a part of speech tagging. In all cases, we are using these techniques. Now, let's look into some of the neural network architectures that are fundamental to modern NLP. RNN and LSTM. These are types of neural networks designed to work with sequences like sentence. Let's start by comparing these regular neural networks and recurrent neural network or RNN. Normal neural network look at all the input data at once. Kind of like seeing a picture all at the same time. They don't remember anything from before. Every input is treated as a brand new without context. This works fine for things like images, like that, but not so well for data that comes in order, like sentences or time series. In that cases, this normal neural network will not work. Here comes the RNN. or recurrent neural networks, they are designed to work with sequences, data that comes step by step, like words in a sentence or notes in a song, like that. What makes RNN special is that their feedback loop. They pass information from one step to the next. This means the network has a kind of memory that remembers what happened before. That is the specialty of RNN. Okay, if we are saying an example, this take a sentence like the cat sat on the mat, where the RNN reads the word sat, then it remember cat came earlier. In the word the cat sat on the mat, that is the word. So when RNN reads the word sat, it remember the just before it had a word cat. So it understand that sat is about the cat. Without this memory, the word sat wouldn't have much meaning on its own. So basically, RNNs read words one at a time, keeping a track of what they have seen before to better understand the full sentence. Even though RNNs have a problem, they can forget important information in the sequence if the sequence is very long. That's where LSTM comes in. LSTM or long short-term memory, it is a special kind of RNN, recurrent neural network, designed to remember important information for a longer time. Regular RNNs can have trouble remembering things from far back in a sequence because information can get lost or forgotten as the network processes more words. This is called the vanishing gradient problem. Here, LSTM solves this problem by using gates. These are like filters or checkpoints inside the networks that control what information should be kept and what information should be updated or what information should be forgotten. Like that, LSTM solves this by using gates. There are three main gates in an LSTM. One is forget gate, another one is input gate, and the last one is output gate. Forget gate decides what old information to throw away, which means what information should be forgotten. And input gate, it decides what new information to add. And output gate decides what information to use for the next step. So, because of these gates, LSTM can keep important details for a longer period of time, which helps to understand complex sequences better than a normal RNA. This makes LSTM great for tasks like translating long sentences or paragraph and speech recognition, where understanding context is a key, where we use LSTM, and in some tasks like writing or generating meaningful text that flows well. So using LSTMs, NLP models moved beyond simple word by word understanding, and it started to grasp the meaning of entire sentences and longer text. In simple terms, you can think of an LSTM as a smart reader who decides what to remember and what to forget while reading a story. So they don't lose track of important details. That is the LSTM. After RNN and LSTM, transformers came in picture. And it is a neural network architecture used for performing machine learning tasks, particularly in natural language processing and computer vision. The transformers architecture was first introduced in a paper titled Attention is All You Need in 2017. It signifies a departure from traditional sequential processing method, replacing them with parallel processing for improved efficiency. And unlike RNNs and LSTM, which reads word one by one, transformers look at the whole sentence at once. This lets them understand the relationship between all words, not just nearby one, like LSTM do. They use a mechanism called self-attention, which means the model decides which words are important for understanding the meaning of each word. For example, in the sentence, the bank by the river is beautiful. Here the word bank is related to river, not money. So if we are understanding the complete sentence, then only we can understand bank is related to river, not to money. So because transformers process all words in parallel, they are much faster to train and better at handling long and complex sentences. Transformers are the basis for many modern NLP models like BERT and GPT. So next, I told you already, there are some core concepts for transformers like self-attention. We can check what are the core concepts of transformers. The main one is self-attention, and there is positional encoding, multi-head attention, encoder-decoder. These are the core concepts of transformers. Let's start with the self-attention. One of the key idea in transformers. It helps the model figure out which word in a sentence related to each other. Each word is converted into three types of vectors here: query, key, and value. These are used to calculate how much focus or how much attention one word should give to another one. For example, like let us say a word, the cat didn't chase the mouse because it was not hungry. Then the model needs to know what it refers to. Is it the cat or mouse? So this self-attention helps the model to understand that this it means the cat. So if it completely understands the sentence, then only it can understand that this it refers to which character, which one, the cat or mouse. That is what doing by self-attention. It convert each word into these three vectors: query, key, and value. So it is used to calculate how much focus should be given to one word compared to another. Next core concept is positional encoding. Unlike RNNs, transformers don't read sentences word by word. They process the whole sentence at once. So they don't naturally know the order of the words. So to fix this, we add positional encoding to each word's embedding. This gives the model the information about the position of each word in that sentence. Okay. Next core concept is multi-head attention. Instead of just using one self-attention layer, transformers use several layers of that called multi-head attention. Each head look at the sentence differently and picks up different relationships or patterns. Why we use this? This makes the model better at understanding all the different meanings and context in a sentence. That's why we are using these several layers, multi-head attention. Then coming to the last concept, core concept, encoder-decoder architecture. This is very important in tasks like translation. The encoder reads the input sentence. For example, if the input sentence is a French sentence, it turns that sentence into a useful representation, basically a smart summary. Then the decoder takes that summary and generates the output sentence. Each encoder and decoder has multiple layers. Encoder have self-attention and feed-forward network, while a decoder also have self-attention and feed-forward, but they also include encoder-decoder attention also. This helps the decoder to focus on the relevant part of the input sentences while generating output. Okay. Now, transformers are very powerful and useful in many different areas. These are some of the important applications like NLP task, speech recognition, then computer vision, recommendation systems, text and music generation. These applications shows how powerful the transformers. In NLP task, transformers help with the task like translating languages, summarizing long text, recognizing names or places in a sentence, and understanding whether a text is positive or negative. That means sentiment analysis. And these are happening in the NLP task. And coming to speech to text, they can listen to audio and convert spoken words into written text accurately. Now, coming to computer vision applications, transformers are used to identify objects in images, classify pictures, and even create new images. Now, recommendation systems, they help websites and apps to suggest things you might like based on what you have looked at or used before. Using your history, these websites or apps will suggest things for you. Then coming to the next application, text and music generation. Here what transformers do is they can write articles, stories, or even compose music automatically. So these applications shows how transformers are used across different fields. These are some of the applications of transformers. Now coming to BERT, which stands for bidirectional encoder representations from transformers. It was created by Google to help computers better understand language. What makes BERT special is that it reads text both ways, like left to right and right to left. This means it can understand the meaning of a word by looking at the word around it before and after. For example, take a sentence. I went to the bank to deposit money. Here, the word bank can mean a place where you keep money or the side of a river. So, without knowing what are present before and after the bank, then only we can decide what it means. So Bird looks at the whole sentence and knows here the bank means a financial institute and not a river. That is what happening in Bird. Bird is based on a model called the transformer, which connects every words to every other words in a sentence to understand their relationship better. It is trained on huge amount of text like Wikipedia, like that. So it already understands a lot about language. Then you can fine tune Bird for your specific needs, like teaching it to detect sentiment or for answering questions like that. You can fine tune this Bird. People use Bird for tasks such as understanding if a review is positive or if the review is negative, like that, or answering questions based on text, and for classifying emails, summarizing long articles, and even creating new sentences, we can use Bird. Because of Bird's ability to understand context deeply, it has improved many language applications, making tools like Google Search and virtual assistants. They are Bird making these tools much smarter. Now coming to LLM. LLM is large language models. They are very big computer programs designed to understand and generate human language. They learn by reading a huge amount of text from books, websites, and articles like that. This helps them understand not only words, but also facts and how these languages works. Here, some well-known LLMs are GPT-4, ChatGPT. You may know ChatGPT, and you had used this. What makes LLM special is that they can write text that sounds like a real person wrote it. For example, if you ask ChatGPT, what is the capital of France? It will answer the capital of France is Paris and something like that. If you want a short story or if you want an essay written, then again, ChatGPT, we can use ChatGPT. It can do that too. So LLMs can even help programmers by writing computer codes. For example, we can ask to write a simple program that add two numbers, and if we want, we can even make use of ChatGPT to write a long code, and it will give us the code. They can also summarize long articles into short summaries for saving our time. So that LLMs use the transformers technology here. Think of you can think transformers like a team that looks at every words in a sentence and decide which words are most important to understand the meaning. This what we mentioned by attention in previous slide of transformers. Because of this, computers can now have conversation with us in a natural way. They can help with our homeworks, answer our questions, write emails, and much more. In short, LLMs are making computers smarter and easier for us to do our task or even to talk with them. Now, to understand the foundations of NLP, we need to know its core concepts. These are the main core concepts of traditional NLP. First is lexical analysis, and then coming syntactic analysis, semantic analysis, word embedding. The lexical analysis or tokenization, we can say like tokenization. This means breaking text into smaller parts like words or phrases. That is mean by this tokenization or lexical analysis. Next one is syntactical analysis, which looks at how words fit together in sentences. For example, it helps computers to understand grammar. That's why that is what a syntactic analysis. Then comes semantical analysis, which is about understanding the meanings of a word and how these words are related to each other. That is the semantical analysis. Finally, word embedding, which will do word embeddings will turn words into numbers. So computers can analyze them. These steps helps computer understand language step by step from simple word to complex meaning. These are the main core concepts of traditional NLP. Now, let's see the first one, lexical analysis. So in an NLP, the first step is lexical analysis. This means breaking down a sentence into smaller pieces called tokens. Usually these tokens are words. For example, if we have the sentence, the cat sat. Lexical analysis breaks it into three tokens: they, cat, and sat. By breaking sentences into tokens, computers can work on each word separately. It's like reading a sentence word by word to understand it. This step is very important because computers need to know where words starts and end before they can understand the sentence. So this is a very important step, breaking the text into small pieces. Now, after breaking the sentences into tokens, the next step is syntactical analysis. This means understanding the grammar and structure of the sentence, like how the words fit together. There are mainly two ways to do this: top-down approach and bottom-up approach. Top-down approach starts with the whole sentence and divide it into parts like subject and verb. While bottom-up approach starts with the words and build the sentence up by connecting them, as its name indicates. So these are the two ways to do syntactical analysis. Now, for an example, in this example, the cat sat. The computer figures out that the cat is the subject, and subject means the one doing the action, and sat is the action or verb. So understanding the structure will help the computer to know who is doing what in the sentence. So to understand that meaning, we are using syntactical analysis. Next is semantical analysis, where the computer tries to understand the meaning behind words and sentences. Sometimes a word can have more than one meaning. For example, here the word bat that can mean an animal that flies at night or a tool that used in sports, like that. So the computer needs to look at the whole sentence to understand which meaning is correct. This is called word sense disambiguation. Also, the computer looks for connections between words in a sentence, like who is doing what to whom. This process is called relationship extraction. This step helps the computer really understand what the sentence really means, not just the word. So we are using semantic analysis to understand the meanings of words and sentences. Finally, we have word embeddings. Computers don't understand words like we do because they only understand numbers. So word embeddings are a way to turn words into numbers. Then only computer can work with them. Here given an example, king and queen. They are close in number space because they have related meanings. But if we are giving king and apple, they are far apart. This helps the computer know which words are similar or connected, which improves its understanding of language. So using these word embeddings, computer can better understand meanings and relationships between words, and so that it can make NLP task more accurate. So traditionally, when working with the textual data, we would use methods like one-hot encoding to represent words. This means each word is represented by a vector that is mostly filled with zeros, except for a 1 at a single position. While this might work for small vocabularies, it becomes a big problem when dealing with large data. One-hot vectors are high dimensional and sparse. And imagine having tens or hundreds of thousands of words. Each word is represented in a huge vector with mostly zeros. This is not only inefficient, but also loses any notion of similarity between words. That's where word embeddings comes in. They help us to reduce the dimensionality. So we are working with compact dense vectors instead. More importantly, they allows us to predict the context around a word given. Then, which is extremely helpful in capturing the meaning or usage of a word. With embedding, we will get a numerical representation of word that carries real meaning. So essentially, embeddings allows models to understand semantic relationships and similarity between words. They form the base of modern NLP. Now, how are word embeddings actually used in machine learning workflows? Think of it as a three-step process, from words to numeric vectors, and we are using in training or inference. When we prepare text data for a machine learning model, whether it is for classification, translation, or sentiment analysis, whatever it is, we first transform the text into embeddings. These embeddings are then passed to the model. just like any other form of numerical input. This helps the model to learn better representations, especially because similar words have similar vectors. So if a model sees the word like joyful during training, it can still understand something about the word happy during inference, even if it never saw it before, because they share similar embeddings. These embeddings can help to learn better representations. Embeddings are also transferable. You can use pre-trained embeddings like word2vec, GLOW, or FastText and apply them to your own data set. This saves training time and often leads to better results. Okay. Now, to make this embedding more understandable, let's take a fun and relatable example. This is a emoji embeddings. Suppose we collect text messages or tweets from social media. We can notice that certain emojis tend to appear with certain emotions or topics. For instance, for crying emoji, that often appear with words like miss, sad, or heartbroken, while this fire, the fire emoji that shows up with amazing, trending, like that, we have noticed certain emojis are coming with certain topics. Anybody speaking? Okay, so we can use this pattern to assign vectors to each emoji based on the words and context they appear in. These conditions act like our features in word embedding, and the result is a numeric vector for each emoji. Here you can see if it is happy, emojis will be like this. For sad, excited, sick, you can see. So the emoji vectors for emojis will be, for happy, this emoji is appeared to be 1010. Here you can see. So the same principle applies to words. Here what we do, we plot or analyze these emoji embeddings. We will find that emojis with a similar usage end up close together in the embedding space. Okay, look, you can see these two images will be coming close together in the embedding space. This is their numerical representation. Here it comes close. So the same principle applies to words. If two words often appear in similar context, their embeddings will be similar. Even if their spelling or structure is completely different, even though their numerical representation or their word embedding space that will be similar. This example shows how we can learn word meanings from usage rather than having to define it manually. NLP, which is very different from traditional NLP because it uses deep learning, especially new type of computer programs called neural networks. These neural networks, especially ones called transformers, they learn directly from huge amount of text data. Instead of people telling the computer what to look for, the computer figures it out by itself from the data. This is called end-to-end learning because the computer takes in raw text and gives out a result without needing much help from people. Modern NLP models needs a lot of data to work well. The more data they have, the better they become. That is modern NLP. So data is a important fact for modern NLP. And a big new idea in modern NLP is called transfer learning. This means that a large model is first trained on lots of general language tasks. Then It can be adjusted or fine-tuned for specific jobs, so that we can make it very flexible and powerful for that task. This new way of doing NLP has led to amazing improvements in what computers can do with languages. So that is about modern NLP. So we talked about traditional and modern NLP now. We can compare traditional and modern NLP now. Here you can see these are the features and how it is happening in traditional and modern NLP. Traditional NLP uses rule and statistics. It was very limited and not very flexible, but needed less data, as we said. But coming to modern NLP, it uses deep learning and transformers. It is more powerful, more flexible, but it needs lots of data. However, because these models learn so much on their own, it can be hard to understand exactly how they make their decisions. They are often called black boxes. Reason they are called black boxes. Overall, NLP has moved from using human rules to letting data, computers learn patterns from data. This is how NLP has improved from simple to advanced method. So this modern NLP can handle complex language and tasks that traditional methods cannot. Is there anything to ask? Anybody asking anything? Okay, let me continue. Okay, now before diving into advanced natural language processing, training any machine learning models on text, the very first thing we need to do is preparing our data. This step is called pre-processing, and it is very important step. You can think of it like raw data will be messy. If you are ever looked at social media data, customer reviews, or scrapped web content, you will know that it contains a lot of unwanted data like emojis, punctuations, typing mistake, errors, inconsistent capitalization. In scrapped web content, it will contain HTML tags, hashtags, and all kind of things that machines can't easily understand. So our goal with pre-processing is to clean, structure, and normalize the data so computer can analyze it. That's what we are doing in our preparing data. So yeah, here in this pre-processing techniques, first we will clean the raw text. This could, one second. Okay, in the pre-processing, first we will clean the raw text. We could mean removing extra white spaces, removing unwanted digits, unwanted spaces, unwanted digits, which are not relevant in the data, and removing the punctuation marks or removing HTML tags like that. We will clean the raw text in the first stage. After cleaning, we then tokenize the text. As we said already, tokenization means splitting a sentence or documents into smaller units. Usually, how we split, we will split as words, or sometimes we will split as sentences. For example, as we said, if we say I love natural language processing, we will split it into tokens. Like if we are splitting as words, we will split as I love natural language processing, like that, tokens. Then after tokenizing, finally we will normalize the text. Normalization means making all the words looks consistent. This might mean converting all characters to lowercase, fixing common typos or misspellings, and expanding the contractions. Like sometimes we might have used don't, so we will expand it to do not. Like that, we will normalize the text. So all of these steps are about making sure that two words that means the same thing are treated the same way by the computer. Now, you may wonder why this step is more important. I already said it is very important step. So you may wonder why it is that much important. Because if the text we given to our model is inconsistent or messy, the model can't understand, or it will have a hard time to learning anything useful from that text. So clean and well prepared text makes our model to make understand better, more accurate, faster to train, and easier to interpret. So that's why these steps become very important. Before giving the data to model, we have to clean and prepare our text. So you can think this pre-processing as a laying the foundation step. Without this step, everything else we build will be unstable. That much important step is pre-processing. Now, let's look at some of the most important pre-processing techniques. In this section, we will explore 3 core techniques used in pre-processing. Those are tokenization, lemmatization, and stemming. Tokenization is the process of breaking text into smaller units like words or sentences. This is the first step for almost any NLP task. Now coming to second one, lemmatization. Lemmatization and stemming. They are both ways to reduce words to their base or root form. So these 3 are the foundational or main key pre-processing techniques. Let's take them one by one. Tokenization. It is the process of splitting a block of text into smaller units called tokens. These tokens are usually words, but depending on our task, they could also be subwords, characters, or even sentences. Let's simply understand it as, imagine you are trying to study a book, but all the words are jammed together with no spaces or no punctuation mark. So it would be unreadable. So tokenization is what adds those boundaries. It identifies the meaningful segments. So let's look at an example to see how pre-processing works. Suppose we start with a simple sentence, I like apple. After tokenization, it will tokenize like this. Each word into one token and punctuation also. If we were splitting it as a sentence, then it will tokenize. This will like I like apple as one token. Here, why it is 1, 2, 3, 4 tokens given. Here we are tokenizing like word tokenizing. So it will split each words into one token. So we got 1, 2, 3, 4 tokens. If we are using sentence tokenization, which will tokenize each sentences, then I like apple will be tokenized as one token. I like apple. So according to our task, it can be tokenized as words, characters, subwords, sentence, and anything. So now the machine can analyze and process each word independently if it gets this type of tokens. As I said, there are many type of tokenizations. One is word, which will split text into words. This is the most common one. And the next one is sentence tokenization. It is used in summarization or translation techniques. It will break the text into sentences, as I said. Then a character tokenization. It is used in some deep models. Then subword tokenization. Models like BERT use this tokenization to handle unknown or rare words. Here given an example, unhappiness become unhappiness. Like some words are tokenizing. So why it matters? Why is tokenization is important? Many NLP techniques like POS tagging, that is part of speech tagging, and NER, named entity recognition, embeddings, they all work at the token levels. So it ensures consistency in downstream processing. That's why this tokenization is very important. Next, we have lemmatization. This is a linguistic process where words are reduced to their base or dictionary form. That is known as lemma. Unlike stemming, which we will talk about shortly, after covering lemmatization, we will come to stemming. This lemmatization uses grammar rules and a dictionary to understand context. You can see the example. And, is, and are. These all will be reduced to their base or dictionary form. B. Then running, ran, runs. These all will be reduced to their dictionary form run. Here better will be reduced to good. You will notice that these are not just truncated versions. They are true base forms. Here we are using the dictionary forms. After reducing also, it has a meaning. So why use it? Why this lemmatization is important? Lemmatization ensures that different grammatical forms of the same words are treated as one unit. This reduces the vocabulary size and helps in better semantic understanding. For instance, if you are building a search engine, someone searching for running shoes should also find results for a ran or run. So lemmatization helps to make this possible. For example, here given that children are running and eating apples. So after lemmatization, it will be the child be run and eat apple. See how every word is reduced to its meaningful core. So that helps model to recognize patterns more easily. Now let's talk about stemming, which is a simpler but more aggressive version of lemmatization. Instead of relying on grammar rules or dictionaries, stemming applies brute force rules to chop off prefix or suffix. For example, here you can see caring. That is reduced to car. Studies reduced to study. Agreed reduced to agree. As you can see, sometimes it cuts too much. The output may not even be a real word, but it reduces variation first. This often used when speed is more important than precision. If the precision or accuracy is important, then we can't use this stemming. We will use lemmatization. Or if we are thinking about the speed, we want a speed process, then we are using stemming. For example, if you are processing millions of news articles or tweets in a real time, stemming might be better fit than the lemmatization. If we are comparing lemmatization and stemming, some of the examples are the word running. In lemmatization, it will become run. In stemming also, it will become run. But for a word better, you have seen here In lemmatization, better will be reduced to good. But in stemming, better will be reduced to bet, B-E-T-T. So you see, stemming might lead to inaccuracies, while lemmatization aims for correctness. It will always use what reduced to their base or dictionary form, unlike the stemming. Okay. Look at an example to see how pre-processing works. Suppose we start with a simple sentence, I liked apple. After tokenization, this sentence is split into tokens, which are just the individual words and punctuation, like this, as we said. And lemmatization, this step reduces words to their base or dictionary form. For example, the word running become run, better, as an adjective become good. This helps the computer understand that different forms of the same word have the same meaning. That is the usefulness of lemmatization. And stemming is similar to lemmatization, but it's a bit simpler and sometimes less accurate. For example, as we said, running becomes run, jumps become jump. Stemming just cuts off the end of the word. So sometimes the result is in the real word, but it's very fast and works well for many tasks. Beyond the core techniques, several other pre-processing steps are commonly applied, which include special character removal, spelling correction, NER, normalization, POS tagging. Special character removal removes unwanted special characters from the text to clean and standardize the input, as the name suggests. Spelling correction, as it's saying, correct the misspelled words to improve the quality and consistency. Then NER, that's named entity recognition, that identifies and classifies the name the entities like person, organizations, location, dates, like that. Normalization, standardize the text data, include converting words to lowercase stemming, like that. It will standardize the data. And POS tagging, assign each word in the text its appropriate part of speech, like noun, verb, adjective. So here, these are the other pre-processing techniques. You can see stop word removal. Stop words are common words like they, and, to, is, like that don't usually carry important meanings on their own. For example, in this sentence, you can see, I like apple and banana. So after doing stop word removal technique, it will be like apple, banana. So it removes common, less meaningful words to focus on important content. So what all it removed? It removed I and. Those are some common words. So it removes those common words and it gives the final result as like apple, banana. That is what happening with stop word removal. And this helps the model to focus on the very important data only. Then, but sometimes in some cases, like take sentiment analysis, where words like not, that is very crucial. So in one example, I do not like this. If the word not is removed, then sentiment becomes misleading. So use stop words removal very selectively only based on your use case. Then only we can get the correct answer. If we are using this stop word removal in sentiment analysis, the result will be incorrect. Like that, according to your use case, you have to decide which all pre-processing should be used or not used. Then coming to lower casing. This step is about case normalization, turning everything to lowercase. So here you can see apple with a capital A and this apple with all lower cases and apple upper cases all become after processing. It will become small cases apple. So these all words will be treated the same. This reduces the vocabulary size and prevents the model from mistakenly leading case-based distinctions. Okay, that is what lower casing processing. And coming to special character removal. Many texts, especially from social media or web scraping, they will be filled with special characters like emojis, HTML tags, hashtags, extra punctuations, like that. Many special characters will be there. So these characters can create a noise for models. For example, here, see, it has given with many special characters, this word. So removing these words will help to reduce the clutter in our input data. So that's what special character removal is doing. After pre-processing, it will get only the needed text. Now, spelling correction. This is especially helpful in user-generated content like tweets, comments, or for product reviews. Like here, see, I really like this one. So this is, you can see this is very incorrect, misspelled. So before processing, word is like this, and after using spelling correction, we will get the correct sentence. Here, these misspelled words are treated as unknown by models. So correction improves both performance and accuracy. There are many tools for these, like SimSpell, PySpell Checker, and even from the transformer model, BERT, we can use all this for spelling correction. Next is named entity recognition or NER. It identifies and categorizes entities in text like people, locations, organizations, dates, etc. For example, here, Sundar Pichai is the CEO of Google. Here, after processing, NER extract Sundar Pichai as person. It will give the tag as person, and for Google, like organization. This is valuable for information extraction, knowledge graph creation, question answering system. In such cases, this NER extraction is very valuable, where we use NER. Then normalization. Normalization, this is a broad concept where it includes many small adjustments like expanding abbreviations and standardizing some formats and conversion. Like here you can see Dr. Smith visited on this date. So this doctor is an abbreviation. So after normalization, it will be expanded to doctor. And then Smith visited on this date. It will standardize the date format as December 10, 2025. Then again, this normalization can convert the numerals to words also. These steps ensure uniformity in how text is represented. This is critical for downstream tasks like a document classification or a document summarization. In such cases, this normalization is very critical, where we can use this. Now, next is POS tagging. POS tagging assigns grammatical labels to each word. For example, the quick brown fox jumps, where POS tags there is determiner, quick adjective, brown adjective, fox is a noun, jump is a verb. This will help in understanding sentence structure, building grammar-aware applications like chatbots or grammar checker. In such cases, we can use POS tag. When it comes to implementing NLP tasks, there are several powerful libraries and frameworks that makes our work much easier and more efficient. Each has its own strength and each has a best suited for different kind of projects. So these are some of the key NLP libraries and frameworks. Let's start with NLTK. NLTK, or which stands for Natural Language Toolkit, that is NLTK. It is often the first library people learn when they start with NLP. It provides a wide range of tools for basic NLP tasks like tokenization, stemming, part of speech tagging. Like for those tasks, it provides so many tools. Next, we have Spacey. Spacey is designed for speed and efficiency, making it a top choice for production environment and real-world applications. It is much faster than NLTK, and it is optimized for tasks like named entity recognition, dependency parsing, text classification. For such tasks, we use Spacey. And if you are building a chatbot or recommendation systems or any applications where speed matters, Spacey will be a great option. Another one is Hugging Face Transformer Library. This library has revolutionized modern NLP by giving easy access to state-of-the-art pre-trained models like BERT and GPT. With Hugging Face, you can build advanced applications such as text generation, question answering, and sentiment analysis with just few lines of code. That is the main advantage of that. It is especially useful when you need cutting edge performance and want to leverage the latest research in deep learning. You can use transformers from Hugging Face. Finally, we have scikit-learn. It is a general machine learning library. It is widely used in NLP tasks like text classification or other supervised learning problems. It provides simple and effective tools for building and evaluating machine learning models on the text data. So each of these library has its own strength. NLTK is the great for learning and experimenting with core NLP tasks, while Spacey is fast and efficient for production tasks like NER and POS tagging. Hugging Face transformers provide access to advanced models, and scikit-learn is widely used for text classification. These are the key NLP libraries and frameworks. So I can show you this NLTK. Here you can see NLTK Natural Language Toolkit documentation in Google. Here it is provided what is NLTK and how it can be used. Some simple things you can do with NLTK. This is tokenization and POS tagging doing with NLTK, and here doing named entity recognition with NLTK. And to installing NLTK in your system, you can see instructions here. Here you can see NLTK requires this Python version and how to set up the Python environment in each system. How can we install NLTK? The information is given in this site, and here they have already provided so many example usages of NLTK modules. Here you can see usage for classify. Here for classifying or classifies label tokens with category labels. It is as a health spot. It can classify that given text. How it is working, you can see so many examples are given here in this page. You can refer this.
അല്ല ഇത്രയും മാത്രം മതിയോ? ഈ മെയിൽ മൊത്തം വേണമെന്നോ? ഇതും വേണമെന്നോ? അങ്ങനെ എന്നാ കൺട്രോൾ കീ കൊടുത്ത് വേറൊരു ഇതായിട്ട് അറ്റാച്ച് ചെയ്താൽ മതിയോ? 2 പേപ്പർ ആയിട്ടോ? ഉദ്ദേശിച്ചത് ഈ ഇതില്ലേ, അതായത് പുള്ളി പറഞ്ഞത് നാളെ ഇവിടെ നിന്ന് പോണം എന്നുള്ളതും പിന്നെ ഈ പിള്ളേരുടെ ലിസ്റ്റും കൺട്രോൾ കീ കൊടുത്താൽ എന്താ വരുന്നത് നോക്കി. എല്ലാവരോടും വരുന്നു.
Okay, next one is Spacey. This is the documentation of Spacey. Here you can see in the usage how you can install Spacey in your system. Installation instructions are given here. If you are using pip, you can use these commands to install, and using conda. If you are using conda, you can use this command to install Spacey. And there are the models, trained models and pipelines for Spacey. You can refer this page also to get an idea about the Spacey. In coming to transformers, here you can see here how can install transformer in the system. And there are resources given and its documentation. Everything is given in this page. Please refer this. And for scikit-learn, this is machine learning in Python. It is widely used in NLP for tasks like text classification and supervised learning problems. It provides simple and effective tools for building and evaluating machine learning models on text data. Here again, you can see instructions to install in your system, user guidance, examples. So to get a better understanding, I have included some code samples, very simple code samples on these and basic NLP processing, pre-processing techniques. Okay, first I will show the key text processing techniques using the NLTK library. Here I have included some examples from NLTK library and some from scikit-learn. One text classification example from scikit-learn, and from Spacey, these pre-processing techniques, how we can do using Spacey, and with a small lines of code, how we can do sentiment analysis. This is what I have included in the demo session. So first, let's begin with the tokenization using NLTK. Okay. As I said, there are many tokenization techniques like word tokenize, sentence tokenize, regular expression tokenize. Here, first and important tokenizations are word and sentence tokenization. Here I am showing a combined example, which starts by sentence tokenize to break down a paragraph into individual sentences. Here, our input text is hello world, NLP is fun. Let's learn tokenization. This is the input text. And how we are doing this? First, we will do sentence tokenize. Then after sentence tokenizing, we will do word tokenize also. See how it will work. Okay. So this is helpful when you are dealing with large documents or paragraphs. And here you can see input text is hello world, NLP is fun. Let's learn tokenization. And it is by using this sentence tokenize from NLTK tokenize module, we use sentence tokenize and word tokenize. First, we are using sentence tokenize and giving this input text. So what it did, it cut down into each sentences. So our output is hello world is one token, NLP is fun is another token, and the third token is let's learn tokenization. So it break down as the tokens. And behind the scene, it uses a model called Puncti sentence tokenizer that has learned punctuations and abbreviations rules from a corpus. So next one is word tokenization. Once we have the sentence, we use word tokenize from this NLTK.tokenize module to split each sentence into words and punctuation marks. That is what happening here. Internally, this is powered by again another model, tree bank word tokenizer model, which follows specific rules to separate contractions, chords, and punctuations. Here you can see it took first sentence and using this word tokenize, it tokenized into hello, word, and this punctuation mark. So this is the tokens from the first sentence. Here in this loop, it is happening. So it is first it will take first sentence and then second sentence, it will again tokenize NLP is fun and dot mark. So you can see what is the difference between this sentence tokenize and word tokenize. According to our use case, we will use this. Okay, this is the tokenization using NLTK. Now we can see another tokenization methods. As I said, not only word tokenization and sentence tokenization, there are many other tokenizations are available in NLTK.tokenize module, which include regular expression tokenization and word punctuation tokenization. Like that, there are many tokenizations available. Here you can see. This is regular expression tokenize. This is uses regular expressions to define custom tokenization patterns. Here, it is using a regular expression pattern. Okay. Which allows to define custom rules using regular expressions. If we are using this one, this /w plus matches one or more word characters, and this @ matches the @ symbol literally, and /dot which matches a literal dot, and /s plus which is any sequence of non-white space characters that didn't get matched before. This kind of control is very useful when you are dealing with a structured input like emails or file paths. In such cases, we are using this regular expression tokenization. And coming to next one, tweet tokenizer. Here, what we are doing is, when working with the social media data, traditional tokenizers don't perform well. Tweet tokenizer is designed to handle emojis, hashtag, and mentions. So in this example, we tokenize a tweet that includes emojis and hashtags. Each of these elements is preserved as its own token. That's what makes it ideal for NLP on tweets. Then MWE tokenize. It allows to treat specific combinations of words as single tokens. This is useful when you want to preserve named entities like New York or like that. We define the combinations we want to keep together and then apply it to the token list. The output shows New York as a single token. It will not cut it. Okay. So that is MWE tokenization. We can see how it is working. Here you can see regular expression tokenization. As our rule saying, it took all words @ dot, everything from this text. And for input tweet tokenization will take emojis and hashtags as it is. And here in this MW tokenize, we had defined New York as one token. So it take New York as one token. Like that, there are a lot of tokenization techniques in NLTK. We can make use of it as per our use case. The next one is stemming. Okay. Stemming, as we said, stemming reduces words to their root form by chopping off suffixes. It is a rule-based method. So here it is using Porter stemmer. It is one of the oldest and most widely used stemmer. We only stem alphabetic tokens to avoid punctuations. For example, here this processing will become process. This explore will become explore without this E. This helps to reduce the vocabulary size. Let's see how it is happening. Here, our input text is natural language processing is fun. Let's explore it. After stemming, the stemmed words will be, look at this. It is cutting the ending of the words. So natural become nature. Language is like this. Processing become process. Like this, after stemming, we will get this type of stemmed words. This is stemming and lemmatization. Lemmatization, it returns the dictionary form or base form, which is known as the lemma. Unlike stemming, it produces a real word. So let's see how it is working. This is the input text. After lemmatization, it gives a real word. Natural become natural, language, processing become processing, explore, like this. Let's, you can see this let's become let, like that. This technique requires knowledge of the word's part of speech for high accuracy. That is lemmatization. Now coming to word, stop word removal. Stop word removal. As we already mentioned in the session, stop words are the most common words in a language like is, they, and this don't add any meaning to our context. So we remove them. Here, we also use this is alpha to eliminate punctuation. This is especially useful in applications like search engines or classification task. Here you can see natural language processing is fun. Let's explore it. Filtered tokens is, it removed all the stop words or all the common words like is, it removed is. You can see punctuation marks. It removed it. That is what happening with stop word removal. And here one more thing, POS tagging. This part of speech tagging. It assigns each token a grammatical tag like noun, verb, adjective, like that. Let's see. Here our input text is natural language processing is fun. Let's explore it. After processing through word tokens, it will come to POS tag each tokens. So each token will get assigned with a tag like noun, verb. You can see here. Here NLTK uses averaged perceptron tracker under the hood. These tags help with a downstream task like named entity recognition and syntactic parsing. This is what happening behind the scene. So this is from NLTK, and from Spacey, there is some pre-processing we can do. Yes. Spacey is a powerful and fast NLP toolkit, which is used for tagging, parsing, named entity recognition, like that. Unlike NLTK, which is more modular, Spacey wraps many pre-processing steps into a single unified object called a doc. That's how Spacey is working. Like you can see here, first we will load the Spacey and a language model. This SPACY requires a pre-trained language model to process text. Here we load EN Core WebSM, which is a small English model. This gives us access to tokenization, lemmatization, POS tagging, NER, and more. This all will be get from here. So then we are creating a doc object. You can see text is Apple is looking at buying a startup in the UK for $1 billion. So what is happening here is passing the text through the NLP pipeline, which will create a doc object. This object is like a container with rich linguistic annotations for each tokens in that sentence. Then using these, we can, from this doc, we can tokenize, lemmatize, POS tagging, stop word removal, everything we can do. Here tokenization is handled automatically as the text passes through the pipeline. Each token in the doc object is a word, punctuation mark, or symbol. SPACY handles these type of complex cases like the contractions and such complex cases and can also be handled from SPACY. Then coming to lemmatization and POS tagging, each token comes with a lemma. Here you can see each token will have a text, token will have a lemma and POS. So then SPACY marks common words, that is the stop words using token is stop. Stop words using is stop, like this. To filter out punctuations and digits, it also has common methods. Then named entity recognition, we can see from here, it is taken from ent.txt and ent label. Let's see how it is working. You can see here. First, it did a tokenization. And from each token, it provided lemmatization and POS tagging. You can see token is this, lemmatized word is this, and POS tagging. And after that, you can see filtered tokens and named entity recognitions. For each token, it is giving entity label. Apple is an organization, like that. This is money, like that you can see. So as you can see, SPACY provides a highly efficient and very easy to use pipeline for many pre-processing tasks. So it is ideal for production systems because it balances speed and accuracy. That is the importance of SPACY. Coming to transformer. Transformers are more modern and powerful. Okay. Here, this library allows us to access cutting-edge NLP models with very little code. We will see how simple it is to run a sentiment analysis using a pre-trained transformer model. Here, what we are doing is we are using a pipeline of sentiment analysis. Here, we are importing pipeline from a transformer model and we are using this sentiment analysis pipeline. Actually, there are multiple pipelines available in Hugging Face transformer module. Like this sentiment analysis, we have text classification pipeline and NER pipeline, text generation pipeline, summarization pipeline, question answering, fill mask. Like that, there are multiple pipelines available. So these pipelines, how it is working, like it will tokenize the input and prepare tenses for model input and runs the transformer model, then post-process the output. That's how these pipelines are working. And here we are using this sentiment analysis pipeline. It loads a pre-trained model and tokenizer designed for analyzing sentiment. It will load that. the pipeline automatically tokenizes, encodes, processes, and decodes the input text. So the result will be a list of dictionaries with sentiment labels like positive or negative, and along with the confidence score. That will be the result. So what is happening behind is the input string is passed through a tokenizer like word piece tokenizer, and the transformer model process these token embeddings in layers to understand the full sentence context. Finally, a softmax layer outputs the sentiment class probabilities. That is how it is working. So let's see how it is classified this word, whether it is a positive or negative. Here, see, in just a few lines of code, we were able to do a sentiment analysis. So this Hugging Face transformer, which makes easy to use powerful transformer models with minimal setup. Here you can see this word, it is labeled as positive with a score of 0.99. So again, you can see it's very simple code with the 3 lines. So that is the use of transformer. Now coming to scikit-learn. Scikit-learn, here we are doing a text classification. Here we will manually extract features from text and feed them into a classical models like Naive Bayes or logistic regression. So what here is happening, we are loading these models, count vectorizer, multinomial NB, make pipeline, then sample data. We are giving the sample data and corresponding labels, whether the data is positive or negative. And then we are creating the model pipeline. Here we are creating model pipeline using the make pipeline. Here passing count vectorizer and multinomial NB. This count vectorizer convert text into a bag of words numerical format. Each document is turned into a vector of word counts. And this multinomial NB, which is a Naive Bayes classifier, which is good for discrete features like word counts. And we will give this to make pipeline. This combines vectorization and classification into one pipeline. Then trains the model using model.fit, which is used to train model on a label data. Then using model.predict, we can make predictions. So what is happening behind the scene is count vectorizes, tokenizes the text and build a vocabulary. Naive Bayes computes word likelihoods per class. Then this classifier predicts the most likely label for the coming new input. So here we have given a new text. The service was not good and we have to find what is the prediction. Here you can see the prediction is negative. Here this approach is fast. Scikit-learn models are easy to train and deploy, especially for smaller data sets. While not as powerful as transformers, they can still use in some cases. Like if it is a small data set, or we can give the exact data with labels, then we can use this scikit-learn. These are the simple demo to get an understanding on how NLP is working. NLP pre-processing main techniques are working. Okay. Here I have provided all of these examples here to refer. Okay. This is for sentiment analysis. This is for text classification. I will share these slides with you all. You can refer this. Now, pre-processing evolution from manual to automated. Pre-processing has also seen a significant shift with the advent of modern NLP. In traditional NLP, pre-processing was a very explicit and often manual process. We do tokenize, stem, lemmatize, and remove stop words, all to create a clean, structured input for our models. Each of these steps was a distinct operation, and human linguistic expertise was heavily involved in these roles, in these steps to define the rules. So, but coming to modern NLP, while tokenization remains vital, the nature of this tokenization has changed with the subword tokenizers that can handle more complex phenomena. The biggest difference is that many of the features we used to engineer manually, like semantic relationships or these grammatical roles, those are now implicitly learned by the deep learning models themselves using embeddings. So the focus has moved from explicitly preparing features to providing raw or minimally processed text to powerful neural networks that handles the feature extraction internally. So it leads to more robust and more generalized models. That is the evolution from manual to automated in the case of pre-processing. Then NLP has a huge impact across numerous industries, transforming how businesses operate and how we interact with the technology. Like as shown here, in healthcare, NLP helps analyze vast amount of medical data, assisting doctors and researchers in making more informed decisions and accelerating breakthrough. And coming to finance, it's crucial for identifying fraudulent activities and understanding market trends, providing a competitive edge. Then customer service, it has been revolutionized by chatbots and virtual assistants powered by NLP, offering instant support and improving customer satisfaction. Even in education and legal field, NLP is streamlining process and providing valuable insights, making complex tasks more manageable. So this slide highlights just a few of the many real-world applications where NLP is making a significant difference, and it impacts continues to grow. This is only a small of the real-world applications. So thank you all. This is from today's fundamentals of NLP. I hope you got a clear understanding on the fundamentals of NLP. So in the upcoming sessions, led by my colleagues, you will be introduced to even more advanced topics like word and sentence embeddings, transformers and self-attentions, and how these models learn and respond, and LLMs. So stay tuned, and we are only just beginning the journey into the exciting world of LLM. So I'm winding up my session. Thank you so much. Thank you. Thank you all.
We have now come to the close of today's session. On behalf of SJCG Palai and TCS Kochi, we sincerely thank Ms. Rahila T for her insightful and engaging session on foundations of NLP. As a token of gratitude, we would now like to present a virtual memento to you, ma'am. Kindly accept this gesture of appreciation from the entire SJCG community. We also thank all participants for their active involvement. We look forward to your presence tomorrow as we continue this journey into the fascinating world of NLP and explainable AI. Wishing you all a pleasant evening. Thank you.